Hi everyone, we are Group 9 from the 10 a.m. section, and our project was a COVID-19 database. As many of us are aware, nearly 1.5 million people have passed away in the past year due to COVID-19. The purpose of our website is to gather and present important information on the pandemic to assist and educate people around the world. Before we get started, we'll take a minute to introduce ourselves.
My name is Cameron. I am from Katy, Texas, and I'm primarily a backend developer.
Hi, my name is Jeffrey. I'm from Austin, Texas, and I'm a full stack developer.
Hi, my name is Shrivu. I am from Houston, Texas, and I was also a full stack developer.
Hi, my name is Vassi. I'm from Flower Mound, Texas, and I worked on the front end.
Hi, my name is Yash. I'm from Katy, Texas, and I was a full stack developer.
Like most teams, we use React as our primary front-end framework. We use Ant Design for a lot of our front-end components and Nevo as a graph creating library in React. We call our API from the front end using a library called Axios, and the API itself is designed in Postman. The API service is written in Flask, and we interface with our Postgres database using SQL Alchemy. Both our front end and back end service is hosted on Google Cloud. For testing, we use Jest for our front end components and Selenium for our end-to-end tests.
The countries model is the primary model users will view if they want to search for or compare countries and their related data in a single location. The model displays general data on the country, its geographic information, a few visuals, and some related links to provide further information. A few challenges came up when we elected to display countries in a card format rather than the tabular format used for case statistics and risk factors, but this ultimately led to a better visual appeal for the most basic of the three models. The countries model can be reached by visiting the Countries tab inside of the nav bar. We'll start by entering a few search terms into the search tool. As you can see, the search query is highlighted in the web page, and all related results are provided to the user. You can see that all the entries in the model can be sorted by many values including country name, alpha codes, total cases, and total population. These results can also be paged through, and a user can change the number of entries they wish to view per page. We will now select a few countries to list for comparison. After we have selected our set of instances, we will click Show Comparisons, which will place all selected countries side by side for ease of viewing. From here, we can select and deselect candidates for comparison simply by checking the provided box. Now we'll select a specific country instance to view from the model. In each instance, our site provides information on the country, some helpful images, an interactive map, COVID-related news, and finally a few helpful links for further browsing. Finally, we'll visit the visualization for our countries, which displays population against the area of a country on a logarithmic scale. Hovering over each data point, which is colored by region, provides the specific data on that instance in the graph.
The case statistics model is the main model that features all the statistics and information regarding COVID-19 in each country. Statistics include and are not limited to the total and recent stats for the number of cases, deaths, recoveries, active cases, and tests. The main challenge for this model was figuring out a way to nicely display all the data in an organized fashion, especially the data used to render the graph, as it needed to be reformatted and structured to be used. Let's go ahead and take a look at the case statistics model page. When the page loads, you'll see a table that showcases all the countries for which we have case statistics on. Similar to the other models, this page also has the ability to search, filter, sort, and compare instances. The first thing I'll do is sort all the countries in descending order by the total number of cases. As seen on news, the US is in the first row because it has the most cases. I'm also going to add it into my compare list so I can compare it later on. I also just want to focus on the countries that have the most deaths, so I'm going to use the filter tool to do just that. Now the table has significantly less amount of rows as well. Let's add a few more countries, and if I want to revert the table back to its original self, I can either get rid of the filter by resetting it here, or I can just clear all the filters by this button. Now let's go ahead and look at the search. I can search by any title within the table itself, but specifically I want to look for New Zealand. There it is. I'm going to add it right there. Now if we go ahead and look at our comparisons, we have all these countries here, and just to fill it out, I'm going to add one last one. And here we go. So the comparison view is just a good way to compare all the countries based on the statistics featured in the table, where the countries may not necessarily be next to each other in the table. You can look at total cases, deaths, and recoveries, and active cases as well. Now let's go ahead and see an instance page now. So here is the instance page for a country. Each statistic is grouped off into different sections. So at the top, you have the total statistics, just as a general overview. Then you have recent stats, which kind of show the daily stats of the most recent data API was updated. Then we have general stats, which show some rates, such as the fatality rate and infection rate. Some links to other models for this instance. And then the part I think is the coolest, which would be the trends and visuals. So this graph here was built using the Nevo library, which is a package or tool built on top of D3. If you hover over it, you can see the depressing death line, and then you can also see the number of new cases added each day. And lastly, we have a map of the US itself. Now let's go ahead and check out a visualization based on the case statistics model. The visualization we chose to implement features the top 20 countries with the most COVID-related deaths. If you hover over any country, you can see how many deaths it's had so far due to COVID. It's just another way to see and compare each country numerically in terms of area. Yeah, that's the case statistics on this website.
The risk factor statistics model is what we use to look at each country's different types of risks due to COVID-19. We felt that risk factors were relevant to this project because people in different countries experience different symptoms and strains of the coronavirus. We analyzed life expectancy, human development index, population density, and Gini. On our site, under the Risks tab, you can search a specific country or even a specific statistic. For this demo, I'll filter the life expectancy to only show instances between 70 and 90, and I'll choose a few to compare. Now I'll sort the data, which I can do alphabetically or numerically in either direction. I can also search for a specific country and add these to my comparison. Looking at these comparisons, we can see that though these countries have similar life expectancies, their population densities vary greatly. For more information, I can click on this actual instance and learn a few more statistics that relate to COVID-19 directly, such as coronavirus risk level, hospital beds per 1,000, or cardiovascular death rate. We can also take a look at the visualizations we produced from getting the Gini indexes of the top 5 countries with the highest inequality. So we can see the 5 countries represented here, and if you drag your mouse over them, you're given the name of the country and the corresponding Gini index.
The global news page is unique in that it was created entirely to satisfy a user story from Phase 1. The page displays COVID-19 related news articles from around the world in a simple card layout with the title, image, date, and description. An API endpoint was specifically created for consumption by this page. All of the news articles were collected from News API, which I will briefly touch upon again later. Here is a brief demonstration of the global news page. As you can see, here is the aforementioned user-friendly card layout. Each card is clickable and will navigate the user to the original article. As you can see, the articles are from several different countries. The data in our dataset was mostly scraped from APIs, but we did also scrape a single static JSON file from our Weldon data, which was particularly helpful for collecting risk factor statistics. Risk countries was primarily used for country information, COVID-19 API was mainly utilized for case statistics, and News API was used to collect both country-specific news and global news for the page I just demoed. Here is a quick overview of all of the endpoints that are available on our API. Each of our models has two dedicated endpoints, one for retrieving all of the model's instances and another for retrieving a single instance of the model based upon a unique identifier. Additionally, the attributes query parameter may be included in the request in order to specify which of the model's attributes the client wants included in their response. The global news and global stats endpoints were developed for very specific uses in our front end. I have already covered global news, so I won't reiterate that. The global stats endpoint serves global totals and daily new values for COVID-19 and is intended for use on our splash page. The search endpoint is probably the coolest in my opinion. The client sends a request to the endpoint with the query parameter, and a list of related countries is included in the response. The database search is implemented using PostgreSQL's full-text search feature, which operates on the textual fields in the country's model. The site-wide search feature on our website leverages the search endpoint to populate some of its results. As you will see, a search for Central America yields results for countries located in that region. Capitals are another attribute that is searchable. As you can see, a search for Paris yields results for France.
As a team, we communicated and divided tasks really well. We were able to work on our own separate streams of tasks in parallel and then cleanly merge them when the time came. We learned front-end and back-end web development as well as how to connect them using a structured, RESTful API. We also discovered the extra work required to turn our local code into a production-deployed website. In each of our tasks, we became an expert on our team. We taught each other what we learned as well as how they could use the things that we've built in their own tasks. I believe the biggest thing we could have improved on is testing. Despite having a full suite of tests, we broke master a lot, and discovered several bugs after features were already deployed to the production site. Peer reviews helped us look back at each member's personal contribution, but didn't change much about how we worked as a group since we worked well together. When the team was asked what puzzled us, the response was, "What would happen if you answered false on an attendance quiz?"
That basically showcases our website and all of its features. We definitely learned a lot and had a great time building it. We hope you love it as much as we do. Please be careful out there in this pandemic, and thank you very much for listening.
Our provider group was collegesearch.me. They did a great job picking relevant models for their topic of searching for colleges. When picking a college, the location and foods could be critical in making a decision, and they included detailed information about them. The REST API had intuitive endpoints for accessing their models, although we did run into some issues with TLS and the response formatting. They implemented most of the user stories that we suggested, and they worked with us to add several features that we felt were important to us as college students. Especially in times like this, college affordability is important for many who plan to go. Using the data on College Search, we learned a ton about financial aid provided by colleges, as well as the prices associated with living and eating nearby. I believe the biggest thing that they could improve on is production stability. With many of our tasks requiring us to visit their site, we found it difficult when their site would just give us a server error and force us to wait until things were restored. One thing that puzzles us about their site is how some of their filtering works. In some cases, there aren't units or default values, so it's not always clear how to use certain fields. For collegesearch.me, we created a visualization for each of their models. For states, we created a scatter plot of the amount of veterans that live there versus total residents. For restaurants, we visualized the average price level of places in each state. We also use a bar chart to compare the full-time enrollment of several colleges.
And we'd like to end the presentation by inviting you all to check us out and give feedback on our work for the semester. Obviously, COVID-19 is an extremely important and current issue, and our site could be a useful resource to help others. Finally, we'd like to thank everyone for giving us the chance to share our work, and to Professor Downing, the TAs, and our proctors for their help in developing the site. Thank you.